This is the 3 rules of test-driven development are useful and incomplete. I'd like to start off with just a statement that I like. Laszlo Koskela had this in his book, Effective Unit Testing. I like this, but I think it needs a little adjustment. So this is my version. Because you can write code that the computer understands, but other people don't, or it's very difficult. And that's not a good thing, right? Because then eventually you're going to wind up looking at code like that, and it's a real pain. So part of my goal is when I'm writing code, I want people to be able to understand it and see what it's supposed to do and have it make all kinds of sense like that so that they don't have to try and figure things out. And one of the great things about doing test-driven development, any kind of test-first processing like that is, it helps you write code that's more understandable. Okay, so that's the end of the advertisement. So this is reasons why you should listen to me. I am not primarily a JavaScript person, but I like JavaScript. But I am a Java champion, and I got voted as a Java 1 Rockstar at a nice conference many years ago. And I got to contribute to some of these books. The nice thing about these books, though, these were an experiment that O'Reilly tried and found very effective. Everything that's in those books are non-copyrighted. You can take that. In fact, somebody has out on Amazon, I believe it's this first one, the 97 Things Every Software Architect Should Know. They have their own version of it. They took the contents, put it into their own book file, and put it out there, and they're selling it. So it's a nice thing. Okay, today's agenda, pretty simple. Just a quick view on what is TDD. Some people have different ways of thinking about it. What are the 3 rules? How are they useful? How are they incomplete? Because I have to pay off what I gave you in the title. What's the solution? A quick example and a summary. So we'll just start off with the beginning. So test-driven development, a lot of people, this was their introduction to it. Kent-Beck put this book out in 2002, I think it was. And there was a previous book, Extreme Programming Explained. This is one of the first agile processes that did well. In fact, this XP, if you've done it, is really good for developers because it lets us focus on what we're doing and what makes the most sense and how to make it all work. And you don't have to have other people do it if they don't want to. You can still be doing XP and test-driven development and get the benefits of it. But in Extreme Programming Explained, there were 12 practices, and one of them was called test first. The idea was you would write your test before you write the production code. And then Kent-Beck, a couple of years later, expanded that into this book, which is still, it's not a thick book. There's not a lot to it. But this is the one that most people know him from, or know TDD from. And people considered him to be the father of test-driven development. He says he's not. He just rediscovered what they were doing many years ago, as in during the NASA Gemini project, when they were trying to get a man, put him into orbit, bring him back safely back to the planet. The people who were writing the software for that were using a form of test-driven development. It's kind of funny. Back then, of course, they had big wheels of magnetic tape to hold data, right? You didn't have disks and stuff like we have. And so the idea was you would take a data tape and using the information on the data tape, you would create manually a result tape that had the expected data from when the program runs. And then you would write your program, read at the data tape, compare it with the tape that you created by hand, saying, okay, here's the expected results. What did I get? If they match up, your program works. If they don't match up, either you've got a bug in your program or when you were creating that data tape, there was a problem and you have to go back and find it all. Okay, things have gotten much better since then for us. Test-driven development is like the most efficient and effective way of doing this I know. It's a 3-step process. And if you've read the books, you've seen it. You first write a failing automated test. This is called red because when you run the program and the test fails, it puts the output in red. Second part is you write the production code that'll make the test pass, which is called green because the tests all pass and they're in green. And then there's the last step, which is a key. You refactor to clean up any mess. And refactoring is basically, it's changing the code any way you need to, as long as you don't change what it does. You can change how it does it. You can rename things. You can split things apart, mush things together, whatever makes the most sense. But this is where we clean up the mess we made while we were doing the first two parts, writing the test and making the code work. Refactoring is, okay, now you've got a test that passes, you can safely change your code, right? And as long as the test still passes, you know you haven't broken anything. So that's the red-green refactor part. TANSTOF. Anybody know what this acronym means? Yeah. TANSTOF is, there ain't no such thing as a free lunch. It's an old one, but it's true. There is no such thing as a free lunch. My kids, when we were young, would say, yeah, but when we go to the hotels from vacation, we get free breakfasts. And I asked them, I said, do you think that you can just walk off the street and get the free breakfast? And they went, probably not. So, okay, but TANSTOF was, there ain't no such thing as a free lunch, and as with doing anything new, there's some cost in doing TDD. Right? It's going to take some time to get good at, and when you first start, you get something like this happening to your performance. It goes down, right? It's like, this is something that's supposed to make you more efficient. So what's going on? Well, it's the same thing that happens anytime you do something new. You're having to not do what you know how to do and work on the new stuff instead, and so you're not as efficient as you would be otherwise. And so what happens is a lot of people start seeing this, and it's like, this is taking longer. It's not supposed to do that, and they'll quit because they think there's a problem. And it's just, no, you haven't gotten used to it yet. It hasn't become part of what you do, so you're having to manually, mentally remind yourself, oh yeah, I got to write the test first, then I write the code, then I do the cleanup. And it just takes a little bit of time. Okay, so yeah. If you exercise with people, you know it's a lot easier if you have a friend to go running with or whatever you're trying to do. Same thing here. If you can find somebody else who's also interested in doing test-driven development, you can partner together while you're doing it, and each one of you will help support the other, and it gets easy for both. So, okay. So that's a quick rundown on test-driven development itself. What are the three rules? And how are they helpful? And how are they useful? And how are they incomplete? So originally when I found this, it was online, and so this is Robert C. Martin, the guy who wrote the Clean Code series of books, if you're familiar with him. He originally put this out in 2005 in October as part of a blog post. And it says, you're not allowed to write any production code unless it's to make a failing unit test pass. Okay, and number two is, you're not allowed to write any more of a unit test than is sufficient for it to fail, and compiling counts as failing. Now, if you're using something that's interpreted, if it's not runnable, right, it's failing. And number three, you're not allowed to write any more production code than sufficient to pass the test. So just because you wrote a little test doesn't mean you can go write 3 libraries, right? You write just enough to pass the test. And that's because the test can only cover so much, right? So if you start writing things outside of it, you're not getting the benefits of the TDD. And you can't refactor it because you don't have anything to make sure you haven't broken anything. When he got to publishing his first book, Clean Code, he cleaned it up a little bit and decided they were laws and not rules. So you're not allowed to write any production code. So you see, instead of you may not, instead of you can't, it's you may not. So he's getting a little more, a little less pushy, but it's still the same idea. Okay, so those are the 3 laws as written in the book. So why are they useful? Well, okay, first, switching back and forth between writing the test and writing the production code is very valuable because first, in order to write the test, you have to understand what it is the system is supposed to be doing. Right? What is it that I'm trying to actually do here? No questions. So if there's any details that you're not sure of, you need to check with somebody, either the business people or a more senior person who knows the rest of the system. But switching back and forth keeps you from getting into flow, at least initially. I think if you've been doing this for a while, you can get into a state of flow. I don't know if you guys are familiar with the idea of flow. Flow is a state of mind where everything just seems to line up and you can just start cranking out code, or depending on what you're doing. For programmers, you're writing amazing code very quickly, it's very effective, it's awesome, and then when you look at it later, yeah, maybe not so much. But it's because you've got this balance of your skill set and the challenge of the problem itself, and you get into this really state, and it feels like being very efficient and effective. By switching sides back and forth, looking at it, when you write the test, you're essentially the user, right? Because you're writing a test that's going to call this method, or create an object, or whatever it's going to do. But you're seeing it from the user's point of view. And so the question is, okay, when I go to create this, what method name makes the most sense? What parameters make the most sense? Which order should they be in? What types should they be? As a user, you see it as like, okay, I've got this data that I want to have processed, this stuff that I need done. As a programmer who's writing the internals, you don't care what the method's called. It's calculate. It's calculating numbers, right? It doesn't matter to the person who's making it, but as a user, you want to have something that's easily understood, something that makes it easy to work with. So that's the first piece. Switching back and forth keeps you from getting stuck in one way of thinking, too, because you're changing your perspective. Okay. It creates a fast feedback loop. If you're writing just enough test code to fail, then that means the first time you mention a class that doesn't exist, the first time you mention a method that doesn't exist, you have to stop. So you write a couple of words and you have to stop, and now you have to switch over and do the production part. But you're only allowed to do enough to make it working, not fail anymore. So you create an empty class, or you create a method that doesn't do anything, and you pop back and forth. And so it keeps you from getting stuck, and you get this nice tight feedback loop showing like, I'm making progress here because I've got the class, I've got the method, it's starting to do things. And so it keeps you more energized, and it's more fun for a lot of people. Encouraging better API design, I mentioned, when you're doing writing the test code, you're thinking about it as a user. What should this look like? What name makes the most sense? What parameters or variables do I want to pass into it? What makes the most sense as a user? So it makes it easier for your end users to be happy with you. Okay, and last year, helps break the current habit. And so because you're switching back and forth and doing this, it makes it easier to actually stay doing it because you're learning stuff as you go. Okay, yeah, second part. So now we know why they're useful, why they're incomplete. Well, the first thing is, when you're doing test-driven development, there are two very common questions. The first is, how do I know what test to write? And the second is, how do I know when I'm done? Right? And this doesn't help with that. It's write a little bit of a test, write a little bit of production code. There's nothing in there that helps you figure out what tests you should have or when you're done, because that's the second part. There's no help knowing when you're done. And the other piece is, if you think about those three rules, it only covers two parts of TDD, right? We talked about the whole, red-green refactor. There's no refactor here. It's just red-green. Write the failing test, write code to make it pass. Write the failing test, write to make it pass. So I initially did this talk back in 2021. I was out walking, trying to figure out why don't people do this more? And it occurred to me, oh, there's some holes here, and so I was part of it. And so I did this talk in 2021 for two different conferences, one in June, one in November. That was Connect.Tech. And then Robert Martin put out a new book. Oh, going the wrong way? Going the wrong way. He put out his new book, Clean Craftsmanship. And he had a new version, right? So right now, so it's not you can't anymore, but this is actually from the book, Write No More of This, Write No More of That. Once again, trying to keep it small pieces, right? Do a little bit of this, do a little bit of that, do a little bit of this. And then 10 pages later, he had this. The fourth law, which is basically, the fourth law is refactoring, is what he said. I've got a lot more to talk about. So, but I thought it was kind of interesting that a little while after the talks that I did, this came out. He didn't say anything here about the first part, which is the other two problems, meaning don't know what tests to write or when you're done. But he did cover the refactoring piece, so that's good. Okay. So what's the solution? Well, for me, I want something that's going to leverage my skills. And for programmers, I think a lot of that is writing code. If you think about it, it's very weird. As programmers, we take other people's detail-oriented, repetitive, manual tasks, and we teach the computer to do it because it's going to be faster and more accurate than they are, and it frees them up so that they can do something that actually takes a brain. But we don't do that for ourselves. Why don't we write tests for our own code so that we don't have to do all the manual testing, all that detailed stuff? And I think part of it is because as programmers, we know that the bugs in our code are there because we put them there. Right? It wasn't intentional. Either it's a typo or it's a misunderstanding of what the requirements actually say, but some programmer hit the wrong key or typed the wrong thing, and it's in the code now. And if you don't have a test, you're not going to know it. So we need to be able to trust it, but I think we want to be able to use writing code as a key piece for this. Like I said, let the computer do the grunt work. We shouldn't have to be stepping through all of these things over and over again. So we should stop writing tests, if you're writing tests currently. And the reason I say this is because a couple of problems. We're going to talk about executable specifications in a moment. Every programmer I know has had at least 12 years of learning that tests are something that happen after something else. Right? When you're in school, you learn something, you take a test. Or you build something and you test it. Right? Nobody's ever said, okay, day one of class, here's the final, fill it out. It doesn't make any sense. So the words we use are important. And that's why I'm saying here, write executable specifications. A specification is something that specifies something. It describes something that doesn't necessarily exist yet. I want a house. Well, what kind of house? I want a ranch house, or I want a two-story house. I want a Victorian. Right? These are explaining what the house is supposed to do or what it's supposed to look like. It helps figure out what the builder is going to need. Right? So if we can create specifications, right, from the requirements we get, we create specifications and use those as the basis for writing our tests, then we know we've got the right track. So specifications, right? They're based on requirements, describe what should happen. You've got to understand the details, right? No guessing is allowed. And this also allows you to separate the design from the implementation, right? I'm thinking about what it is I want to build, and I'm designing it. So it's like, a lot of times, you'll get a requirement or a program, and you'll start sketching out, okay, I'm going to need a front end that does this, I need a back end, I need a database, I need this service, that service, whatever. And we kind of sketch it out onto a napkin or a whiteboard, whatever we've got. But it helps us see the whole system, right? And so being able to separate the design from how we implement it is very critical, because that means we've got the flexibility to change things if we need to. And being able to refactor the code means we can change how the things are set up. They still do the same thing, but now they're decoupled and all those kind of good things. Okay, so it doesn't type here, yes. This is sort of an example of an executable specification. It's a cylinder that happens to be cut so it's the same width or the same height as the diameter. And so if you look at it from one way, it looks like a square, but if you look at it from the other way, it looks like a circle. Right? So an executable specification is similar to that. And we'll show you here. Okay, so we're going to add, so we'll take this, the description, we'll add code to it so it can run like a test. The nice thing is you'll generate living documentation. Living documentation means somebody didn't write this 10 years ago and we've been working with it ever since, and now what the system does has nothing to do with what the description is. We want living documentation, which means that as the system changes, the documentation is kept up to date automatically. And you'll see what this looks like in a sec. Wrong way. There we go. And this bridges the gap, right, between the design and implementation. And for me, it's sort of like this. This is the Rosetta Stone, not the language course, but the actual hunk of stone that was found in Egypt by the French military. And the cool thing about the Rosetta Stone is it's got 3 different languages. It's got a message in 3 different languages, and the message says the same thing. And this was very critical for the historians who found it, because they understood classical Greek, they understood this kind of cursive form of Egyptian, but hieroglyphics they're symbols, right? It's like a little winged something or whatever, and they had no way of trying to figure out what does that mean. But because the message was the same in all 3, they could start going, oh, well, here they're talking about this, and this is saying the same kind of thing, so this symbol is probably something like that, and they were able to key it all together and eventually figure out what the hieroglyphics meant. Well, similarly, right, if we start off with a specification and we add some code to it that says the same thing, and then we have the production code that does what this says it's supposed to do, now we've got a way of saying, okay, something's wrong with the production system. It's not behaving like it's supposed to. Okay, or somebody's reported a bug. Well, what do the specs say? Is it within specs? No? Okay, we've got a problem there. Do the tests pass? They still do. Okay, what's going on? And we can start figuring things out. It'll help us find our way to it. Because we're saying the same thing in multiple ways, it's less likely that we'll have an error that won't get caught. Did I go the wrong way again? Yes. Okay, so my rules for TDD look like this. You write just enough of a specification for it to fail, and not running counts as failing. Very similar to the whole idea of the tests, right? You write just enough that the production goes to the spec runs. Again, similar. When the spec fails for the expected reason, you write just enough production code for it to pass. And then, of course, you refactor so the code is easy to maintain and understand. Similar but different because, once again, we're dealing with specifications that are, we're taking the original spec, we're building on top of it by adding the code to make it executable, and then running that as part of our build process every time we do things. And then the other piece is the zeroth law. If you're an Asimov fan, you know the zeroth law of robotics. But, so the zeroth rule here is you only write a spec when there is an unmet requirement, which means the requirements drive the specifications. The requirements then drive all the rest of it, which is what they should do, right? That's the whole idea of having requirements. They tell us what we're supposed to be writing and tell us when we're done. I've met all the requirements, right? So if you guys have questions, please, feel free to ask away, because we're doing really well with time here. Okay, so what's the solution? And here's an example. So you guys are probably familiar with FizzBuzz. It's really funny because, right, this started off as a kid's game that they would use to learn math, because they're learning how to count by 3s and by 5s and all that. So you'd have a group of kids, you'd start off counting, starting with 1 and start counting, and every time you get to the 3, instead of saying 3, you say fizz, and every time you get to a 5, instead of 5, you say buzz, unless it's a combination of 3 and 5 or 15, where you say fizz buzz. I can't tell you how many senior programmers have not been able to program this, because there's a trick to it. They write this piece of code, they write this piece of code, and they write this piece of code underneath. And so what happens? When 15 comes up, it says fizz. But it's easy. So simple requirements can cause problems because we don't necessarily see the details on it. Okay, so if we were going to do this, we have our team saying, okay, this is what we need to write. If it's multiple 3 but not 5, it's fizz and buzz and then fizz buzz. Then we can create some specifications on it. We'll go through some different scenarios, right? Calling translate on 3 should return fizz, and all that good stuff. And then, do you want to step through this code? Well, I'm going to step through it a little bit because I want you to see how this works. So we start off with the specification, right? Now this is jest. So we're going to describe this instance. Another description here which creates a subgroup. We're going to convert numbers that are multiples of 3 but not 5, and then we've got our first test. We run it, it passes, which I think is stupid. It shouldn't pass because there's nothing in there to pass, but because of the way things started and the way that developers are, we want to keep patterns the way they are. The initial program, X unit, that set this stuff up, didn't have anything that would fail if you had nothing in there. So it's just going to pass. So one nice thing about this is you can do a test.todo up there. To-do says, I'm working on this. And so when you run it, it doesn't break the build, but it lets you know that there's something going on because you've got one to-do that hasn't been done yet. So it makes it a little nicer. Okay, so we're going to go ahead and create our translator. It fails now because that translator doesn't exist, so now we do just enough. We go ahead and create the class and export it so we can use it. Import it over here, and now it passes, just like it did before. Okay. So we go ahead and create our first test. When calling translate 3, it should return fizz. This is going to fail. Well, we had to expect, so that it's actually going to test something. We're saying I want to translate 3, and we expect fizz. It fails because there is no method, so we have to add the method. once again, we're adding just enough to make it happy, and happy at this point is, okay, translate works, it's still gonna fail, so now we've got to add some more. So we do the simplest thing, we're returning fizz. We know that's not right, but at the moment, for the level of what we've done, it's correct. And you could ship this with this level of capability, and okay, it's correct. So that passes. At this point, you stop to refactor. Refactoring, you would look at this and say, okay, well, I don't have any duplicate variables, the names seem reasonable, there's nothing here that makes me go, ooh, I wish I had written this differently, so we're done. First piece, and we go to the next one, same idea. The problem is, of course, that fizz is already there, and so in order to make this fail, we have to change it and force it to fail, so we'll just change it to fuzz. And now we know, and we do this because we need to make sure the test fails when it's expected to. So we'll just change it to fuzz for a second, it fails, so we can go ahead and fix it again and move on to the next test. Once again, refactoring, looking for issues and problems. Stepping through the buzz, right? It failed here because, right, it's just hard code to return fizz, so it's failed, which is good because now we've got something to force us to actually make it do something interesting. So simplest thing we can do, just have a check for, is it evenly divisible by 3? If so, do fizz. If it's evenly divisible by 5, do buzz. And now everything passes. So we go back and we look for the next one. Okay, so 55, when we run that and it passes. Okay. So, once again, we need to make it fail, so we'll change buzz to biz. That way we can make sure the test fails. We set it back, and okay, I'm gonna move through this. So now we're looking for fizz buzz because it's a 15, so we have to put it at the top here so that it doesn't get caught by that divided by 3 or the divided by 5. So if we put it someplace else, the test would have failed, and we've known, oh, there's a problem with the code. But because it's on top, it all passes. Okay, and then we need something for if it's none of the above. So we've got return value here. Now we're running out of space down here at the bottom. So at this point, refactor would be, okay, let me move some space around. So I've got else ifs instead of having else's. Having the blank space, this is something else. Having blank space like this, there's a reason for that, and it's because our brains look at things that are close together and says these are related and things that are farther apart or separated are considered different things. Well, yeah, this is all about handling the divisible by 3, handling divisible by 5, handling divisible by 15, by 3, and by 5. Right? So each one has its own little section, and by putting that blank space between them, it tells the next person, hey, this is a chunk that's all related. This is a chunk that's all related. They're all related for the whole thing, yes, but within that there are subsections that you might want to look at. Okay, so that all passes and is refactored. What else? Calling translate, okay, and then at the end, if it's none of the above, we want to have it throw a type error because they gave us a string or they gave us something other than a number. So we'll put in the code for that. And so we've got a new type error value, it's not a number. That all passes. Now, if you can, I would recommend, when you run these kind of tests and put them in your build, there's an HTML report generator that takes the results and will create something like this. And you can publish this, and if you do, you don't have to get interrupted to find out what the status is, right? If you're sales folk or somebody else needs to know, what's the status with the stuff you're working on? Oh, I haven't even gotten to that yet to do, right? Or it's passing, or it's failing, and leave me alone because I need to figure out what's going on there. Okay? So you can publish that internally to your company or internally to just your organization within the company, and you have fewer interruptions in your day, which is nice. Because it lets you stay focused on things. If you don't want to use something like that, this is what the output looks like on the command line for all those tests. The little green check mark means it passed. If it failed, there'd be an X there, and down at the bottom it would show you part of the errors, so you can figure out what the problem is. Okay, yeah. So there's all this blue stuff here. The check marks, the time stamps, or not time, those are durations on the ends there, and all the stuff at the bottom. Most non-technical people aren't going to care about that. So if you were going to take this information and put it on your website manually, you want to write some code to rip that stuff out so that it looks nicer. Because when you do, and put a space in between the different groups, right, chunking those things that are related, you get something like this. This is living documentation. Every time you run your build, you get a new version of this. Right? Anytime there's a change that's made to the system, if you're updating your specifications so that they still describe what's supposed to happen, then you've got this living documentation that you can show to, like, somebody new joins the team. You don't have to sit down with them and walk them through the code. You've got something that shows every possible way of using that piece of code that you have for the system, right? So it saves you a lot of time, and when they do have questions, it's not going to be something that you can go, oh yeah, whatever. It's going to be something interesting. It's like, oh, we never thought of that. Nobody's ever brought up that idea. Maybe we should take a look at that. So there's a common concern with automated testing, and that is this. If you write automated tests for your code and you have to change it, now you've got twice as much work to do. That's not really true. And part of it is, right? If you're moving something someplace, you're going to have to change the test because they're living someplace else. But because you have that safety net, when you move those tests from one place to another, and then you start moving your code over, you'll know if anything got broken along the way. If you don't have tests and you just move code from one place to another, well, maybe it's all going to work, maybe it's going to break something accidentally and nobody's going to notice. You don't know. So you've got to sit down, you've got to manually go through and make sure that nothing gets broken accidentally. So here, we're verifying the test. All right. Oh, yeah, so this was the code we wound up with at the end, right? So the boss comes back and says, yeah, I don't like it. I do it differently. What do you mean do it differently? No, that's not acceptable. It's been, ChatGPT has it, and now it's been spread out, and now everybody knows how we do our stuff, so we're going to change it. Just do it something differently. Okay, so you write a new version, right? And instead of doing this stuff like that, we'll do it this way and build. So here, it was saying, okay, if I know what it is, then there's the name. Here we're building the value that's coming out based on what do we get, right? If it's divisible by 3, we're going to add fizz. Here it's 5. If it was divisible by 3, we get fizz buzz. If not, we just have buzz, right? So every line pretty much there is different, but guess what? The tests all still pass. Because of the way we did this, and this I guess is an important piece, because we wrote the specification first, and then we wrote the test, the specification is not tied in any way to the test code. They're totally decoupled, right? Other than the names, right? I mean, it has to know the name of the class, has to know the name of the method. But as far as how it works, test has no idea. So you can change that any way you want, and as long as the tests all pass, right, as long as it's working properly, the tests will all pass and everything goes. So it's another way of making sure that you're not accidentally putting the same mistake in 2 places, and so they cancel out, right? There's an error here, but my code doesn't detect it. That doesn't mean everything works. Okay, so that's the end of that. So we're getting to the summary. Yay, summary. Okay, this is what we've talked about. Simple TDD, right? In fact, if you're doing any of the books or any of that, they'll start you off with unit tests. In the book that Kent-Beck wrote, he talks about unit tests, but he also says that what he refers to as units are not what most people think of. Most people think unit tests are the smallest thing you could get, one method that doesn't talk to anything else, that kind of a thing, right? The example we used here, that's like a unit test level. But TDD works very well all over the place, and something I call extreme test-driven development. So you start off with a user requirement, and you write a failing user interface test, which leads to a failing API test, which leads, so this becomes the requirements for the piece below it. So the failing API test is calling a service, and that's failing, right? So you have to create a service test, and now you get down to the low level. Okay, I'm doing whatever the lowest level is here. I'm going to write the code to make that pass, clean up any mess I made, and now I've got a passing test. And okay, are there any other scenarios I need? No? Okay, that means that I should be able to refactor, and eventually I've got a passing service test and work my way back up the chain until I'm back at the top. And now I have a vertical slice through my application, starting from the user interface, going all the way down to the most internal guts we have, right? And it all works. And we know it works because we've got tests that prove it works. So you've got user level requirement tests. It could be hitting your user interface, could be hitting whatever your end users use to deal with the system. But you've written a complete working chunk of it. And it's all been done, and you know that it's correct because it's coming from the requirements that the user had, and that you're meeting all those requirements. So this works, and I would highly recommend it. Okay, I mentioned the test-driven development book, test-driven development by example. This other book on the right is often called the Goose book, Growing Object-Oriented Software, GOOS, because it's too long a name for people to say. But this book actually will walk you through, they set up an example of a, what do you call it? The word has popped out of my head. It's like on eBay when you're bidding on things, right? But it starts off with the front end, goes all the way through the back end, hits the database, and comes all the way back. The idea is that the auction house is a third party, and you're having to call their system separately. So they walk you through this whole thing, starting with what they call a walking skeleton, which is like the barest bones you can have to have something that starts from the user interface, goes all the way to whatever your back end is, and comes back and returns something. And the idea is, when you do this, if you get that walking skeleton set up and into production as quickly as you can, you now have, well, you've got a lot of knowledge as to what's involved in getting something into production, right? Do you have to fill out requirements and go through architectural review boards, all that kind of stuff? But it gives you something now that works all the way through. And so as you start adding more and more features to it, you're doing that built on something that you know is a stable process. So it's a very good book. It follows what they call the London School of BDD, or test-driven development, which is start from the outside and mock the pieces you need at lower levels. There's another version that starts off, it's the Chicago style. You build the small pieces and then you start building on top of them until you get the application you need. The problem with that version, though, of course, is you don't necessarily know what the small pieces at the bottom are going to be because you don't have requirements for those. You have requirements for the overall system. Okay, so that's that. And that's the end of the talk. So thank you very much for your attention. I hope it helps. And if you've got questions, you can get in touch with me at any of these locations or here, or, if you're in Atlanta, every month on the third Tuesday, which was today, the Atlanta Java User Group meets just inside the perimeter. And you're more than welcome to come there and say hi, ask questions, learn something, and most nights we have pizza. So that's it. Thank you very much.